Good morning everyone, and welcome to the first Clyde.Scot Clyde Sustainable Shipping webinar. My name is Ian McGilvray. I'm the co-founder and Executive Director of CDPI, the Clyde Docks Preservation Initiative. We're delivering a series of webinars this year in the run-up to the COP26 Climate Change Conference in Glasgow in November. And these webinars are focused on reducing carbon dioxide emissions from shipping. What the role the Clyde can play in that, and what the opportunities are for the broader maritime sector on the Clyde. So just a bit about our organisation, CDPI, the Clyde Docks Preservation Initiative. We're a social enterprise focused on protection and promotion of maritime heritage on the river and Firth of Clyde. To date, we've been involved in a number of academic collaborations, community engagement activities, and we led a successful challenge to a proposal to build up to 750 flats on Govan's historic A-listed graving docks. And this was refused planning consent by Glasgow City Council in 2018, as many of you may know. And we're interested primarily in the modern context of maritime heritage. So as much as history, heritage is about what we do now and pass on to future generations. And so that means looking at modern industry, technology, current cultural trends and sustainable development. And with climate change, we're really on a knife edge right now, but everything our organisation does is with optimism about the future prospects of the Clyde. And we used to build more than a fifth of the world's ships on the Clyde at the peak of its shipbuilding industry, but we're not unrealistic. We're not expecting industry to ever come back on the sheer scale that used to exist. And we're not here to revel in nostalgia for the past either. Our aim with the Clyde Sustainable Shipping Project is to think about the opportunities and potential for the future, and the networks, resources and expertise we can tap into both in Scotland and globally. And the COVID pandemic has forced us into using video conferencing instead of face-to-face meetings and venue-based conferences and seminars, but it's also shown an opportunity to cast a wider net of collaboration without speakers and delegates having to travel. And of course, there's cost and environmental benefit to that as well. CDPI ourselves, we don't have all the answers, all the expertise or the resources to take all this forward. But what we do have is an identified opportunity to build a network of stakeholders and other experts to address the challenges and to help chart the way for further research, networking and innovation. We're rolling out this programme to look at what possibilities sustainable shipping offers for the maritime future of the Clyde. We're asking if a focus on zero emission shipping could bring back more marine engineering and maritime industry back to the Clyde. And over the course of the webinars, we'll be hearing about projects that are doing just that. And some of you might be asking, if you're not an industry expert, if you don't have the resources, what can you do to support the process? Well, certainly you can help to spread the word, get more people talking about sustainable shipping and the Clyde. And really there are more tools available to do that than ever before. I mean, we've all seen over the past few months how easily social media can be used to spread false information and rumour. And of course, we've seen the ugly consequences of that played out at the US Capitol. But we can also use social media to spread good and encouraging news. You can post about the potential of the Clyde, the opportunities for innovation and sustainable technology, and reducing our carbon footprint. And of course, in the past few days, we've seen the incoming US President rejoin the Paris Climate Agreement, just within hours of being sworn in. And perhaps that's a sign the tide definitely seems to be turning in the right direction. And we shouldn't underestimate the significance of that to global efforts to tackle carbon dioxide emissions. We're aiming to build a working group to address Clyde sustainable shipping. We're looking to recruit participants and stakeholder representatives for that. We need sponsors as well to support the process, but this is just the start of piloting the process, and this is an initiative that will unfold and develop in the coming years. And we also encourage as many others as possible to do their own thing for Clyde sustainable shipping, projects that can raise the profile and further the cause. And this is the webinar schedule. And we still have spaces for guest panelists in the upcoming sessions, so please get in touch if you'd like to contribute. Over the course, we'll be looking at the infrastructure needs for the Clyde. We'll also be talking about the river as a passenger transport corridor and how that might develop, how sustainable shipping relates to import, exports and tourism markets. And in the final session, as we start to count down the days to the COP26 conference, we'll be talking about the policy implications and how these can be approached and influenced. Because certainly if sustainable shipping and marine industry is going to succeed on the Clyde, it will need top-level political backing. But today in the first session, we're going to dive right into the heart of what sustainable shipping actually is and hear about some of the emerging technologies. And I'm now going to hand over to my colleague Liz Gardiner, who will introduce our expert guest panelists.
Thanks very much, Ian. I'm Liz Gardiner. I'm a cultural planner and believe that culture can be a key driver in sharing understanding and consulting communities about sustainable shipping or anything else that we want to engage with. So it's my honour to introduce the speakers today. First of all, we've got Diane Gilpin. She's founder and CEO of Smart Green Shipping, a collaborative industry initiative designed to develop technically, commercially and environmentally superior system solutions for shipping. Diane was recognised in the BBC Women's Hour Power List of 2020. She advises the UK government as a member of the Clean Maritime Council, is a green shipping expert for the Steerer waterborne EU transport platform, and she won an Innovate UK Women in Innovation Award in 2016. Diane co-designed the Ambition 1.5 Global Shipping Action Plan at COP23 in Bonn. Over to you, Diane. You're muted, Diane. Can you unmute yourself?
Absolutely. And share my screen. Can I arrange to have my screen shared, please? Somebody has to. Ah, splendid.
Diane, you should be able to share your screen now.
Yeah, cool. Good. Everybody happy? Can we see that?
Yeah, we can see that clearly.
Good, thank you. Well, good morning, everybody, and it's a great honour and pleasure to be here. I'm going to talk about COP26. I don't know whether any of you has seen the presentation that I did last year in the lead up to COP26, but what I wanted to really talk about is how we have an opportunity. It's really interesting to hear Liz talk about cultural engagement. I think one of the things about shipping and you would know more about it in Glasgow on the Clyde than I would, is the sense of embedded culture that an industry like shipping and shipbuilding brings to a community. And we look at that opportunity aligned with the climate emergency and the nature emergency, and think holistically about what we can do. We are looking to the future and drawing on the past, as Ian pointed out. We can't be stuck in nostalgia. We need to be thinking about what does the future look like so that we can all live within planetary boundaries in a just and social transition sort of way. So my presentation talks a little bit about shipping as a global industry. I talk about the specific opportunity that we see for Scotland and the work that we're doing within Scotland for a whole system solution for shipping. And then I come to two specific key next steps that we are engaging in to deliver our solution. So I think one of the things that's really interesting about shipping is that very few people really appreciate that 90% of everything that we consume is moved by sea. So that may be consumer goods, things that you can see around you, but it may also be raw materials, products that are produced in one country, processed in another, and then sold in another. So there is a vast amount of shipping going on around the world at any one time. And that creates that 3 to 4%, depending on who you listen to, of global greenhouse gas emissions. And that doesn't sound like a huge amount, 3 to 4%, but it's the same as Germany, and it's 3 or 4 times as much as the UK, which is responsible for about 1% of total emissions. So when we're thinking about the problem, this is a country-sized problem, and it's getting worse, it's getting bigger. The emissions from shipping are still rising. And I think that it's really important that we understand that that is not entirely down to obstinacy or climate denial. It is a really huge challenge to bring international communities together to agree a consensus. So the International Maritime Organization comprises 174 countries, and they all come with different challenges, different commercial opportunities, different perceptions on climate change. And so at the moment, the target for shipping is that we reduce by at least 50% the greenhouse gas emissions from the global fleet by 2050. Now, in the context of a climate emergency, that is just not enough, and it's not soon enough. The net effect of setting a 2050 goal is that people don't act with urgency and ambition, and that is a huge risk to the global climate stability. So when we think about greenhouse gas emissions, we're also thinking beyond carbon and into all greenhouse gas emissions, and that includes methane, which we may talk about later in the context of LNG. I think that urgency has been summed up by Nigel Topping, who is the UK's champion for the COP26 event. And he has really highlighted the challenge that we face. Because we work with long-lived assets, net zero shipping by 2050 means you need to be doing zero carbon shipping by 2030, which means we have to have them being ordered by 2027, designed by 2023, and that's only 2 years away. So we are really up against a hard challenge here, but I don't think that it is anything that we should be losing heart about. I think what we need to recognise is that this is a really big opportunity, and we can call upon Scotland's great maritime heritage, and I'll point to areas of other emerging enabling technologies that Scotland's leading in at the moment, to create a really powerful niche opportunity for Scotland in addressing what is known as a hard to decarbonise sector. I would point out that it is hard to decarbonise not for want of technical solutions, but for want of commercial opportunities to create conducive finance and government support for these types of emerging technologies. And we've seen with COVID what an emergency response looks like. And we're not reacting with that level of urgency around the climate emergency. And that's what we need to see. And that's what we will be seeing, to Ian's point about the change of leadership in the States, with much more conviction around addressing the global climate challenge. So the model that we use is called donut economics, and those of you who know of it will appreciate that it's about looking at the economy, the global economy, in a new way. So the economy was kind of invented, economics was kind of invented 2 centuries ago, really, and it was based on physics. And what we now know is that physics is not a good balance for or a good driver for looking at economics, because it has a much greater, economics has a much greater influence from the human element of the population. So we can't predict it in the way that you can predict gravity or any other kind of pure physics response. So this economic model, donut economics, has been designed by Kate Raworth. It is to develop a sustainable, thriving economy for all people within planetary boundaries. It's a really well thought out model, and we're looking to adapt it into the maritime space. Now, one of the challenges we have in shipping is that it's a really diverse sector. And each of these people, each of these boxes that you see represented here, have an interest in developing their part of the industrial structure. And there's very little harmony, there's very little collaboration around how to make these things work together, so that we can really accelerate the progress towards developing a commensurate response to the climate emergency. So what we've done at Smart Green Shipping is to work together with players, actors from all over that infrastructure. That ecosystem is now reflected in our partnership arrangements. So we have aerodynamicists, we have marine engineers from Malin. Chris is here from Malin, he'll talk a little bit later. We have aluminium producers, we work with ship owners, with ship operators, with brokers, with cargo owners. We work with lawyers, insurers, and we work with business model designers to help us all think together about what is the problem that we're really trying to solve here, and who can help us solve that particular problem. And what we found is that once we identify and articulate the problem, we can find the solutions from readily available technology, readily available, and develop solutions in other sectors, and we kind of weave those together to create a solution. So this collaboration, this coalition of the willing, has developed the concept for a flagship of the future. And this is by 2030, in line with Nigel Topping's commitment, or that's not the word I'm looking for, advice that we need to be thinking about those solutions now, is exactly what we're doing. So this is a design that we have been working on for many years, and it's 100% renewable in a wind and hydrogen propulsion solution. But we're also looking at how do we build it in a renewable way. So we use renewable materials, and we buy them and commit to recycling them at their life. So that's a hugely complex system, but we are working, as I say, collaboratively across the piece to figure out how to do that. But every journey starts with the first step, and our first step is to look at how do we retrofit wind onto existing ships. And we've been working in the last 2 or 3 years with Drax, the importer of 80 million tonnes of biomass into the UK to keep the lights on. and with a shipping company called Ultrabulk, so that we can really understand what the technical challenges are of introducing wind power into a 21st century global logistics system. And really what we've discovered, what we've been working on, is a retractable, automated, intelligent, recyclable, affordable and robust system. And we did that by sitting down with the ports, with the crew, with the ship owners, with the class society, to really understand what the challenges were to safety, what the challenges were to line of sight, what the challenges were to operating and optimizing the use of wind. Now, why would we use wind when it seems like such an outdated power solution? And it's because it's free at the point of use, it's clean, it's available, and it's abundantly available to any shipping assets that are available to use it. And so we see the transition of wind in the 21st century fleet as similar to the transition we've seen from onshore wind turbines. I worked for an onshore wind turbine company back in the 90s. The first turbine that went up was 45 kilowatt hours. And now you can probably see from some of you from your windows, up to 20 megawatt machines floating, being developed in offshore situations. So the trajectory of development and innovation is huge. We expect to see that in shipping. But the other key part about wind is that it reduces the overall net demand for alternative fuel. We definitely need an alternative fuel. This is not an either or. This will be working with an alternative fuel, but by using wind now, we can start to drive down emissions in the short term so that we can solve a smaller problem when we go forward into the 2050 target to reduce emissions by 50%. So what we're doing, reducing overall net demand and reducing short-term emissions to air. In order to manufacture the rigs, we think about what's the life cycle impact. We are planning to use aluminium that's produced from a hydro facility. This one's at Fort William. So it's a green materials are being embedded into our solution. And we are looking at how do we install these systems. And this is a system, a crane that Malin have been responsible for installing, retrofitting onto a ship. This technology is not rocket science, it's what Malin are doing regularly. That crane is not dissimilar to the footing and rig that we will be installing onto our ships. I think we're looking to the future. We're looking at using hydrogen. This is one of the island hydrogen facilities. So we can combine green fuel with wind to produce 100% renewable, and we can see how to do it. We just need to start testing the system. So the technical part is relatively straightforward. It requires funding. It's not impossible to do. And I know that from my experience of working in innovation for many, many years, I worked in Formula One, I worked on the launch of cellular telephone systems. If you bring together the right team of people with the right level of commitment, it's a very manageable process. It's also quite good fun. But in order to enable that technology, we do need to involve a little bit of rocket science. These ships need to work within the 21st century logistics system. So we've been supported by the European Space Agency to use satellite information to predict how much fuel saving we can enjoy from our wing sails being deployed on retrofit basis, and to model how we can, on a new build, get a significant more amount of power from the rig. So working with ESA, we're able to develop automated routing tools. And so our first step is to deliver a commercial demonstrator, and that work is in progress to build a ship, or to retrofit a ship that is fitted with our fast rigs, which have been predicted through the ESA system to save about 20% fuel. That can be marketed to some 10,700 ships globally are suitable for fitting this technology. There's a significant market value through not just our business, but the entire supply chain of marine engineering, manufacturing, digital systems, green financing, we can create significant numbers of direct jobs and introduce new safeguard and introduce new jobs. And at the same time, we can save up to 16 million metric tons of carbon. So it's a bit trite, but I like to think of this as win-win-win. We are looking at making a significant social contribution and economic contribution and moving the dial very fast in the problematic shipping area. So our next step is to fit our to build our rig, and we would be anticipating displaying that outside of the conference centre at Glasgow for COP26, 40 metres high, an intention of Scotland's ambition to really address this so-called hard to decarbonise problem. It's only hard to decarbonise if you think it is. And so that's the first step towards delivering this 100% zero emission, fuel independent, commercially viable ship by 2030. So I think there will be questions at the end, or they will be coming up now. So I'll go back to Liz and Ian to tell me what they'd like me to do about answering any questions.
Thank you so much, Diane. Thank you for inspiring us. I'm sure there'll be lots and lots of questions. And yes, we're going to save those until the end. Our next presenter is Dr. Evangelos Boulogouris, and he's a research director at the Marine Transport Research Unit at the University of Strathclyde. He's a principal investigator on many EU and national research and knowledge exchange projects for the last 25 years. With extensive international industrial network, he is involved in the zero carbon transformation of the maritime industry, working in a number of EU-funded projects on batteries, ammonia, and recently hydrogen. Dr. Boulogouris, over to you. Thank you.
Thank you very much. Let me share my presentation. Let me see here. You can see the presentation or my screen?
Yes.
Yes, can
The
see
presentation.
Yes.
In PPT or in slide mode?
It's in the PowerPoint mode. It's not in the full screen slide mode.
Yeah, sorry. Let me just correct this. I have multiple screens and that's why. Now?
That's it, yeah.
Yep, let me do it.
I'll post the screen share.
Yes, excellent. So this should work
That's
now.
it, yeah.
So thank you very much. I'm very honored to present to you today the work which we are doing at the University of Strathclyde, one of the oldest and most prestigious universities in Scotland, in the UK, and globally. My presentation is going to be about the novel solutions for net zero waterborne transport. And I'm representing also the Department of Naval Architecture, Ocean and Marine Engineering at the University of Strathclyde, which was formed by the merger of the departments of SIP and Marine Technology at the University of Strathclyde and the Naval Architecture and Ocean Engineering at the University of Glasgow. Both have been involved in teaching and research in naval architecture since 1881, so a very long tradition. I work at the Maritime Safety Research Center, MSRC, which has been established with sponsorship from DNVGL and RCCL, with a mission to support the development and nurture the implementation of life cycle risk management. And let's say we not only accounting for safety, but also taking into consideration cost-effective measures of risk reduction that leads to sustainable cost-effective safety improvements. We also support the development of a modern regulatory framework to promote the safety culture. Our partners are our sponsors, TNVGL and RCCL, and we have a human capital of more than 30 researchers working with us. Let's see the big picture, which takes us to our main topic today. Shipping was responsible for more than 1 billion tons of greenhouse gases in 2018. And IMO, on the other hand, aims to reduce by 50% the carbon emissions by 2050, relevant to their levels in 2008. In order to do that, IMO needs to, let's say, to take measures. And the calculations right now estimate that we need to produce zero carbon fuels, inject them in a 30 to 40% level to the total energy produced for the maritime, for the shipping sector. So we need those alternative fuels. In MSRC, we are working closely with European partners in a number of different projects. You see some of those running right now. The top three are relevant to our discussion. We have SIP-FC, which introduces green ammonia into shipping, HyShip, which just started with hydrogen, liquid hydrogen propulsion for ships in HyShip, and in TRAM we are investigating the battery-driven high-speed ferries for inland transportation and short sea shipping. So let me start by TRAM, where we are doing something which might be very relevant for the marine transportation or the waterborne transportation in Clyde. We are designing fast catamaran vessels with the mission to develop and validate a concept for waterborne transport by implementing modular designs and production methods with a main focus on electrically powered vessels operating in protected waters. Our main targets are to reduce by 25% the production cost and by 70% the engineering cost in order to come up with novel and feasible solutions. For the TRAM concept, these are the 5 main steps which we have. The modular lightweight construction, which is very important, as I will show you later on with some calculations which we did for a solution in Clyde. Competitive service speed with zero emissions, low noise and vibration levels and high comfort levels. Zero emission drive unit, which should be battery driven or a combination of battery with fuel cells. Smart city integration, which is nowadays very important, and built for multi-stop routes, as would be the case for a water bus or a water taxi. These are the 3 areas where we are investigating in TRAM the application of those solutions. The first one is in Norway, in Stavanger, where we actually built, as we speak, a demonstrator resulting from the research which we did. The round trip length is 23 nautical miles. Then the second case is more closer to us. So it's a case for the London. We work with Umberboat Time Clippers, and we are investigating a round trip with a length of 20 nautical miles. And then we have another case in Belgium with slightly different route and a slightly different purpose. Let's see the British, let's say, case, the UK base. The case for London. This is the vessel which already operates by the Umberboat Time Clippers. The existing vessels will have already a minimum speed of 28 knots. So this is the requirement which we have for our new design. The length is overall is 28 meters, the breadth overall 8 meters. The design draft has a limitation to 1 meter and the number of passengers 220. We are investigating the use of lithium-ion batteries, and as I said, the route length is 20 nautical miles with 12 stops. The process which we are following here, it's holistic. In that respect, we start with the owner requirements in order to see if we can find, let's say, a feasible solution. Then we go to the initial design proposal, design optimization, safety evaluation. We calculate the energy consumption and the fleet optimization. And then if we find that this is not feasible, we go back to the owner and we discuss how this optimization problem can be reset up in order to come up with feasible solutions. In another research project, SIPFC, we are investigating green ammonia as an energy provider on board the vessels. We are building actually a demonstrator which is going to be installed on board this vessel, the Viking Energy. We work very closely with a number of European partners. The interest is mainly from the Norwegian partners, but we have also collaboration from around Europe. We have a lot of, a couple actually, of very large, very significant Greek ship owners who would like to investigate the use of ammonia as a system, an energy source for the vessels in the future. So we are designing a fuel cell, 2 megawatt installed power for the Viking Energy, and then we are going to scale this up to 20 megawatt solutions for the ocean-going vessels and investigate the impact which this will have to their design. A third very relevant project is the HyShip, which just started a couple of weeks ago. We work with a number of partners from Europe, and we are going to build actually a ferry which will be propelled by hydrogen. This is the the concept design of that ferry. We are going to optimize this ferry, and you will very soon understand why optimization nowadays is very, very important when it comes to all the energy consumptions on board the vessel. So this is it just started, and we have very high hopes that this vessel will actually be delivered and will start operating in Norway in 3 years from now, if I remember correctly. So what we did is, with my research team, we tried to investigate how this can be applied in the River Clyde. As you have seen from the previous cases in Tram, a lot of inland transportation is already done by boats which operate at even high speeds. And we know from Tram the number of challenges we are facing when we try to transfer these, implement, let's say, these technologies to the various cases. So we took an existing case, a catamaran which operates already in Clyde. We took some of the main dimensions that it has, and we assumed that the same energy consumption will be valid for the new design. So a retrofit, let's say, of an existing vessel with batteries or other technologies. We assume that we have a short route of just 5 kilometers from Glasgow to Breched, and a long one to Greenock. So these are the stops which we assumed. We measured the distance, that's an approximation, just to have some numbers so we can have a look at what this entails. The energy consumption estimation is shown here. We have a route of, for the long route, 30 kilometers. The speed is 12.5 knots. The power at MCR is 806 kilowatts. We assume that this will give us around a trip of 1.3 hours, and operating at the MCR of 685 kilowatts, operating at 85% of the MCR, we calculated the energy requirement. Now with this, we tried to transfer this fuel, this MGO energy content into electricity, liquid ammonia, and liquid hydrogen versions, and we calculated how much what we are saving from greenhouse gases. You see the emissions which we have for the greenhouse gases. The others, the batteries, the liquid ammonia and the hydrogen are assumed to have zero footprint, and what other emissions we have in general when it comes to the different technologies. So we see how much we are saving from just one vessel in one direction. And then we try to see what the implications would be to the design from when it comes to weight and volume for the longer route. And we calculated this for, as I said, as a retrofit, without although considering the weights of dismantling the existing diesel and reconfiguring the whole engine, just to have an indication of what this entails when it comes to energy. So you can see that the in case we go for the batteries for the long route, this will be quite heavy, because we will need almost 14 tons of batteries, when we are carrying right now 165 kilos of fuel is required. When it comes to liquid ammonia, the weight will be double probably the weight of the marine gas oil, and when it comes to hydrogen, due to this the specific gravity of the liquid hydrogen, it will be quite lighter. On the other hand, of course, we need to take into consideration the weight of the tanks, which was not included in this exercise. Volume-wise, also the battery places a significant constraint to the volume required. So unless we have a very large deck, and these volume requirements will be hard to be met, and they will have an implication to the general arrangement of the vessel. If we go to the smaller route, the short route, with the 5 kilometers until from Glasgow to center to Breched, you see that these numbers come down significantly, and in that respect we can say that the battery-driven boat that operates between Glasgow and Breched might be a viable solution with zero carbon footprint very easily, and with a very good, let's say, it might be much easier to operate and much safer to operate when it comes to other considerations that need to be taken into, let's say, this risk-based approach. The previous numbers suggest that retrofitting in one of the existing vessels might not be the best way forward. So in case we would like to introduce waterborne transport in Clyde, which will take some of the load and the carbon emissions from the roads into the Clyde, and we can establish a network there with water buses and water taxis. We need to have a new approach and new designs, because these new designs will be holistically optimized with a lightweight structure, an optimal hull, an optimal propeller. And we can see from the numbers which we have from the tram project that the power savings can be up or even exceed 50%. And this will make all the solutions much more attractive and much more sustainable in the long run. And with this, I complete my presentation. Thank you very much. I will be more than happy to answer to any questions you may have.
Thank you so much, Evangelos. I'm sure there'll be lots of questions, but right now we're going to move on to Chris Dunn from the Malin Group, who's a chartered engineer and a member of the Royal Institute of Naval Architects. Chris has over 25 years experience in shipbuilding and offshore wind sectors in the west of Scotland, gaining experience in many of the technical departments within the Upper Clyde shipyards during his 17 years with BAE Systems. In 2011, he moved from his position as technical project manager at BAE to the Spanish wind turbine manufacturers Gamesa Offshore Wind, where he helped develop the offshore turbine manufacture, transportation, assembly and logistics strategies for their offshore installations. Chris returned to shipbuilding as a chief naval architect at Ferguson Marine in 2014, leading the design department and drawing office, and responsible for providing technical leadership. He joined the Malin Group in February 2020. So over to you, Chris, from the Malin Group.
Thanks, that's great. I confirm that you can see the screen. It says I'm screen sharing. Yep, all good.
Okay,
Excellent.
Chris.
Well, thanks for the introduction. Yep. Am I unmuted as well? Yes. Thanks for the introduction, Liz. As Liz mentioned, I'm Chris Dunn. I'm a naval architect based in the South Rotunda in Glasgow, where the Malin Group is headquartered. And my background is very much shipbuilding here in the Clyde. I've never really left Glasgow since qualifying. And although I have in recent years spent a lot of my time looking forward, I'm focusing on all things sustainable, partly because I believe that our industry is crying out for all the help it can get to modernize, and partly because it's the right thing to do. As you'll see, my 4 headings today are all questions, and that about sums it up for me. There's a huge amount of activity, but the exam questions are really hard. And as an industry, my view is we haven't yet got the answers. In some cases, we aren't even aware of the questions, but we do know that we need to do something. I'm going to talk about my views on why it's important to modernize, what we can do as individuals to help build the pressure on the industry, and then I'll touch on what I believe the answer might be. But firstly, why do we need to change? What is the issue? Well, I think everyone will agree that we're in times of massive change. Energy transition is the phrase that we're using to describe the shift from fossil fuels to more sustainable and less destructive solutions. There are a bunch of drivers pushing forward this energy transition, but one of the most significant is climate change. It seems that every time we turn on the news, we hear a report of some natural disaster somewhere in the world brought on by man-made climate change, wildfires in California and cyclones in Mozambique, floods in Bangladesh, droughts in Guatemala. Most of this change is based on man-made emissions, greenhouse gases like carbon dioxide, SOx, NOx, methane, all accused of causing the gradual warming of the planet. We have no choice, we simply have to change. And the marine sector, more than most, we heard earlier, 2019, shipping was responsible for 90% of the world trade. CO2 emissions by the global marine fleet reached over 1 billion tons, almost 4% of the global total. It's significantly more than aviation, and as Di said, the scale of Germany. But beyond the climatic damage, there are other serious implications. Health is a massive one. People living within a 5-mile radius of Rotterdam unknowingly smoke 2 packs of cigarettes a week from inhaling exhaust and particulates from shipping. It's estimated that 60,000 people in Europe die each year from heart and lung disease caused by maritime pollution. It's not good enough. Heavy fuel oil, which has been the fuel of choice for big ships, it's untaxed, it's unregulated, it's cheap, it's the dirtiest refined fuel, full of nasties, chemicals, heavy metals, waste products from various other industries. And some of the large ships visiting our major ports burn more than 250 tons of the stuff each day. As I mentioned earlier, international legislation beginning to make a difference. National measures are also beginning to bite. The UK and Scotland in particular making pretty ambitious commitments to net zero shipping. The IMO action to reduce greenhouse gas emissions from 2010, a decade ago, makes interesting reading. The chart bottom left represents the ambition shown. The dotted black line is where they thought we would be if we don't change. Sadly, that is well out of date because we're on track to blow through the 2 billion ton mark 20 years earlier than predicted a decade ago. The horizontal axis at the bottom is the target net zero line. That's where we need to get. It's clear that the IMO sees design and technical measures, which is the blue bit, and even more so innovative measures, fuels and technologies, the green slice. These are the two main contributors that we need to fill that emission gap in our industry's effort to meet the greenhouse gas emission targets up to 2015. It's a big challenge for the engineers ahead of us. So what can we do to help? Well, is it possible to change? Well, my simple answer is yes, and we can make a difference. In my opinion, there are a few things that need to happen to force change. Change needs to be sexy when possible. We don't generally like change, so we don't. So we need to encourage ourselves to adapt. Look at what Elon Musk has done for electric cars. Last year, there were more electric cars sold than diesel cars for the first time ever. And the electric cars moved from a gimmick to a status symbol, unimaginable 5 years ago. And change is possible. We just need the right incentives. Doing sustainable business, it must become cost effective. We generally look for the most cost-effective way to do something, and that is usually not the most sustainable solution. In a world of marine propulsion, diesel is too cheap, technology is too expensive, and because commercial drivers in business are generally more important than social and reputational drivers, then change is slow. Until regulatory pressures force things, or using old technology becomes too expensive, then things are unlikely to change very fast. We need to get used to a mix of energy sources. It's not going to change overnight. There's no single replacement strong enough to dethrone oil and gas. And this is certainly a battle between, it's not a battle between the new technologies. The general belief is that we're heading towards a wide range of solutions, each with particular strengths and weaknesses and market sectors that they'll be best deployed in. Electrification, renewable power is the underlying trend. But these are likely to manifest in a wide range of different guises, batteries and hydrogen, ammonia, as Evangelist talked about, and many other synthetic fuels as well. Even nuclear will be part of the mix. We shouldn't be ruling anything out at this stage. But we individually, we're not going to change our entire economic system, but we can collectively change our behaviors. And that will slowly bring about the desired change that we all know need to happen. We must create that demand, and we do this by changing our habits. We're asking the tough questions, buying ethical products, using sustainable services. Collective actions will make a difference, and suppliers will respond to that demand. The louder we are, the faster things will move. And what does this look like? Well, from a new build perspective, it is moving really fast. It's a moving feast. Advancements in rapid manufacturing, 3D models, computer simulation, material science, artificial intelligence, against a backdrop of rapidly falling costs of renewable energy. It's sprung life into the innovation market. Whole raft of new technologies, and some old ones are now being developed, each covering a range of vessels and applications. We're at it too. That's our hydrogen bunker and transport vessel bottom right. We're currently developing. And these are exciting. But take-up is limited by several factors. Cost, risk, lack of legislation and regulation are huge contributors to this reluctance to adopt. But probably the biggest influencing factor, in my opinion, is the lack of sustainable or suitable infrastructure. Ports typically don't even have the grid capacity to cold iron ships that come in to berth, let alone charge batteries. So we can talk about electrical ships as much as we like. If we can't charge the things, they're pointless. There are no hydrogen bunkers yet, so it would be madness to invest in a hydrogen ship. Where do you find a technician to fix your faulty micronuclear reactor when you get one of those on board? Without serious adoption of these technologies, the ports will be reluctant to invest because they don't know where to put their money. So it's chickens and eggs, and that is a massive problem. My simple math suggests that vessels on average design for between 25 and 30 years life. So as Di says, we need to put things in the water in 2 years' time that have zero emissions, and that's a big ask. Some last longer than that, some less, but on that basis, we'd expect, what, 3 to 4% of the global fleet to be renewed each year. Significant regulations for new builds would be welcome from the climate change perspective, but that opens up a huge range of complicated issues. If the cost of renewal is too high, then owners will choose to extend the lives of their inefficient ships, extension programs, and that's not good. If the infrastructure isn't in place, the owners risk stranded assets. If they can't refuel their battery boats, they're pointless. The list of challenges go on, and 4% of the fleet annually, it's just not enough to justify the necessary infrastructure investment to support them. So the model falls over immediately. And where do we put all this stuff? Lots of questions. The only realistic option, in my opinion, is to encourage the engineers to focus on affordable retrofit technologies and then systematically legislate to force the entire fleet to comply in much the same way that the emissions regulations have done in the market for scrubbers. The owners are then faced with a tough decision, but it's a decision nonetheless. They either invest in their retrofit or they invest in new build, but at least they have an option. And at some stage, the new build option will win, but by then the ports will have seen it coming and put the necessary systems in place. And this is where we believe much of the future opportunity for our business will come from. So we're working really hard to develop new solutions to address the emission issue. Optimization algorithms allow us to run at our most efficient all the time, which is great new advancement. New materials allow us to reduce topside weight, along with automation. Advanced controls mean that we can now reintroduce wind power as the most affordable zero emission retrofit technology. In the past, it was labor intensive, not anymore. We have computers that can make these things run beautifully. Conditioning monitoring allow us to keep our equipment running effectively. Satellite systems allow us to micromanage our voyages to make best use of weather, wave and tide patterns, all to reduce fuel. The image on the top right is an air lubrication system, nothing to do with us, but the bottom two do represent projects that Malin are working on. One on the right is the Fast Rigs project that I talked about. Image on the left represents a different project, which we've developed a full power monitoring system that will shortly be installed on an existing workboat down the Clyde. This will allow us to develop a detailed fuel consumption model of the boat, which we'll use to derive fuel saving systems that, if successful, will allow us to develop a suitable retrofit hybrid system on board, optimized with no loss of performance or capability. Evangelos talked about optimization, but if you don't have data saying what it is doing and what it's supposed to do, you can't optimize anything. So this will give us real life info to an operating boat. Alternatively, we could focus on systems that will reduce emissions, burning less fuel, behaving efficiently, reducing speeds, cold ironing in port, all big contributors to emission reduction. But technology is also helping us to develop fuel saving solutions. There are many systems being designed to promote use of low emission fuels. You've got biofuels, hydrogen, ammonia, a wide range of other synthetic fuels developed from green hydrogen. And green hydrogen is the key here. It's hydrogen that's developed from renewable energy, not from steam methane reforming. Co-combustion systems that inject hydrogen into a diesel engine with only minor modification to that engine to reduce emissions are becoming quite a popular way of reducing emissions. We were the driving force behind the Hydyne project that does exactly that, soon to be commissioned up in Orkney. And of course, there's post-combustion processing. Malin's spin-off company CleanShip, based in the centre of Glasgow, is an industry-leading installer of these systems, completed over, I think, 125 scrubber installations at last count worldwide. So they're pushing that side of the industry. Or we go big and replace the whole propulsion train, typically for some sort of electric drive system that could use renewable power in some shape or form. This is an option which could be undertaken, but with this, it's all or nothing, and likely to be a few years before we see this as a real, true commercial process. Hopefully there'll be a few technology demonstrator projects. We certainly have a few ideas in this area. Bottom left is the BeHydro hydrogen combustion engine. Bottom right is the Vera fuel cell engine that combines compressor, fuel cell, and electric motor in one compact unit. Both fantastic new developments pushing forward this adoption of clean fuels. More exciting for us, a project that we've hoping to start working on shortly, is a Steamology hydrogen steam turbine that we believe will be able to be retrofitted into an engine room to directly replace a diesel engine and still have room and power to spare. Who'd have thought we'd be going back to steam power for ships? But just like sail power, there's some good in there. Of course, there's some challenges to be overcome with fuel storage and non-existent safety regulations, but us engineers do love a challenge, so we'll take it. And what do we do next? Well, we certainly need to do more of this. We need to talk about these issues. We have to have webinars. We need to talk to our colleagues, our friends, and most importantly, the politicians. Our individual choices can make a difference. And if we collectively do start prioritizing sustainability over cost, then industry will respond and change will happen. We need to lobby the administrators and regulators, and they need to be aggressive with their rules before we run out of time. And I'm not scaremongering. A research paper published only yesterday shows that melting on the ice sheets has accelerated so much over the past 3 decades that it's now in line with the worst case climate warming scenarios outlined by scientists. A total of 28 trillion metric tons of ice was lost between 1994 and 2017. This isn't made up, this is true. The clock is ticking. And we need to innovate. Now is a great time to be an engineer. Technical innovation has never been so welcome, and there are a whole pile of very real challenges in front of us that need to be solved. But not just having meetings and drawing things on our screens. We have loads of ideas, but we need to move these to properly engineered proposals. And then we need to push forward to deliver demonstrator projects, all sorts, shapes and sizes, to prove that we can provide the solutions to allow the industry to move forward in this sustainable manner. We need to start putting sails on tankers and fuel cells on ferries. It's time to be bold. It all sounds so easy, but we'll deal with it. And that's all I have to say today. Thanks for listening, folks. Apologies, Ian and Liz, if I've overrun my time slot. That's me.
Thank you so much, Chris. That's salutary and thought-provoking. So I'm now going to hand back to Ian, who's going to tell us, take us to the questions.
Yeah, thanks again for those excellent presentations from our guest speakers today. And I think it really shows that we're at a nexus of science, technology, society, politics and economics here. And all these need to come together to develop and deliver sustainable solutions. But if anyone would like to ask any questions, if you could raise your hand if you'd like to speak, or you can ask questions in the chat. We do have one question submitted in the chat earlier on from Bill Cumming, and he's asking, the scale of change needed in all the initiatives outlined is so great. What key persons do the panel suggest should be headline speakers at the Glasgow Climate Conference this year, e.g. USA President, Chinese President, Elon Musk, etc.? If we could have Elon Musk there, that would be great, I think. So I can just ask all the panelists to
Sure. I think all of the above. Although saying that, as much as I admire Elon Musk, I don't like his view on hydrogen. But still, I think we need to hear all opinions, and we just need to get everyone, particularly these important and powerful folk, speaking whenever they possibly can. And let's get Greta Thunberg up there, and let's get David Attenborough up there as well, because everyone's got a voice, and the more we can get those voices out in every single sector of society across the world, the faster this whole thing will move, because we all really need to realize that the clock is ticking. Huh?
So I would like to go with that. I have a problem with Elon Musk as well. I'm not sure that we should be looking to space to solve our problems when we've managed to make such a hash of the planet on which we live. I'm not sure we should be going off to try and do some other damage elsewhere. I would love to see someone from the new USA administration coming in. I'm really inspired by the fact that they're bringing in Indigenous people's voices. And I think we should be listening to people with different worldviews to our own. So I think that would be a really exciting set of speakers. But I think, well, you know, within shipping, we have a very, very specific challenge. And I've been, as I've seen this question, Bill, I've been struggling. Who would represent, who could talk about shipping in an inspirational way? And yeah, I'm sorry, but I haven't yet come up with anybody, apart from Chris and maybe Evangelos, who just did such a great job. But I think, you know, it's about asking questions at this stage, as Chris says, and, you know, we need to be recognizing that this is the time to be bringing all parts of the community, the social, the economic, the engineering, parts of culture together to solve the problem.
May I?
Yes, Evangelos, carry on.
Yes, I think that it's important to have the main actors who need to take these decisions and implement regulations or put the pressure on in order to take these decisions in the industry. I think that we need IMO secretary to underline the importance of these decisions to the sector. We need also big, let's say, the existing polluters to bring their own ideas of how they think they plan to tackle this problem, and what from investors' point of view, because we need to take this view into consideration, what hurdles, what problems, what barriers they think that exist. So they will offer their opinions into this discussion. Unless we have everybody on board, we will lose time in order to assemble this team that needs to move forward very fast. That's my view.
Okay, good. And we have a question from Jim Stamper. Would using hydrogen in existing marine diesel engines not save considerable energy in the short term, avoiding scrapping existing vessels and building new? Green hydrogen from tidal power works and seems a good source, is it not? Is hydrogen not better than electric, avoiding ecological damage in mining required minerals?
Yep, is that me? Absolutely, I'm 100% behind that. In fact, that's exactly what HyDime does. It takes a hydrogen cylinder on board, injects green hydrogen, and again, the key is green. It can't be blue or gray or brown. It's got to be the green hydrogen, otherwise it's pointless. And it ejects it into the cylinder. And it's a nice soft way to enter as well, because if you do run out of hydrogen, if your port doesn't supply it, you can still run on the traditional diesel, but it does give you an option to clean up your emissions. The challenge we have at the moment, well, there's two. There's the physical challenge. Hydrogen is big, no matter how you store it, compressed, liquefied, whatever, the safety systems that go with it are big, but also that's not a commercially viable option at the moment. So it's fantastic for an R&D project when it's subsidized by government and you have a power purchase agreement for green hydrogen going forward, but at the moment it's not a commercially viable thing to do, so it's going to be really hard to force it on industry. So regulation has to change to either make it, let's increase our environmentally protected areas, so only ships that go in can do that, and that forces them to install these interesting measures. Or we have to subsidize the hell out of hydrogen to make it a viable commercial fuel that people will want to invest in, because until it's commercially effective, it's just not going to happen. So something else needs to happen in the meantime. But yeah, I'm all about that one. Yeah, we should be doing more.
May I? Diane, ladies first.
Thank you.
Sorry.
So yeah, I think the green hydrogen solution is very, very promising, but it's a little bit far in the future given the climate emergency that Chris outlined for us. So we need to be decarbonising, reducing greenhouse gas emissions from everything now that we can through all of the measures that Chris outlined: slow steaming, cold ironing, wind, hull coatings, all of the above need to be installed and retrofitted as fast as we can so that we reduce overall net demand. But the other key driver is that we don't tax externalities. So I refer to the donut economics model. What we measure is around economic growth, and what we need to be thinking about is what's the impact of these emissions onto our global community. So we need to be looking at what's the carbon price. And so we're seeing now really big players suggesting the carbon price, which is currently around $30 or $40 a tonne, being charged at $250 a tonne. And what that would do would be to create the commercial parameters in order to accelerate the development of these alternative fuels. And whilst we are actively promoting wind as a short-term solution, we completely recognise that green ammonia or green hydrogen needs to be developed and implemented into the fleet, because lots of vessels can't use wind. So it's important to be bringing the commercial, the engineering and the policy along at the same time.
So, yes, I think that these solutions which I presented have a different time, let's say, scopes. So batteries is something that we can benefit from what's taking place in the automotive industry already. This is something which we see a lot of developments readily made. We are going to see more developments in the energy storage to weight ratio as we move forward. We noticed this in the Trump project since we started 2 years ago to the numbers which we get right now. Everything has changed significantly. So we are going to see let's say a lot of developments in that area. But batteries are good for the time being only for short sea shipping. You've seen the difference when we change from the short route to the longer route. The numbers are not probably not even feasible in some cases unless you have the right design specification. So batteries are an easy solution, readily available. They are going to get better. They are going to reduce their footprint. Different technology will be introduced. We benefit from the other industries which are working and are investing there, and it's let's say the near horizon solution for short sea shipping. When we go to longer distances, then only ammonia and hydrogen will be available. We work with fuel cells because they have higher efficiencies. They have other challenges, of course, but we see that there are opportunities there. Hydrogen will be the golden grail, but I think this will be, as Chris suggested, this needs a lot of time, both from developing the network, developing green hydrogen solutions, having the market ready and with the supply that is needed in order to do that. So I don't think that this is a solution which we will see in the near future. So this is something that we will see in the future. We need to invest in that direction, but this is not something that will dominate instantly the industry. Ammonia, on the other hand, is much more promising. The temperatures are better. The industry, the land industry basically is more equipped and has a better know-how and using ammonia. There are challenges there. The problem is that all solutions come with a higher cost, and as Chris said, until we have make them competitive for the investors, we won't see the appetite to take that investment risk from their side.
Okay, good, thank you. We have a question from Emily Malcolm, who would like to ask a question on audio.
Hello, and thanks to all the speakers. That was a super presentation. I'm Emily Malcolm from Glasgow Museum's Riverside Museum, and I noted when Chris said it was a great time to be an engineer, and I think historically there have been a number of times when it's been a particularly great time to be an engineer. And just from the three of you speaking, I was thinking about the 1820s, when steam technology was being fitted into small passenger vessels, which had a sort of a huge influence on how that scaled up into larger vessels. And then also the period where developments in steam technology were being carried out at Elders on the Clyde in the 1850s and 1860s. And then, again with Chris talking about the infrastructure, the challenge of resourcing and coaling vessels to use steam technology all around the world. And would the three of you think that there are any there's any value in the historical perspective of how these problems were solved 100, 200 years ago? And does that add any value to what you're doing now, that you're solving the same issues, you have the same challenges, but you're kind of solving them in reverse?
I'll dive in because I'm really enthusiastic about using the past to interpret and inform the future. I think what we are facing in the climate emergency is a great shift, which is the green industrial revolution. So there's a lot of that energy, expertise, capability. And I think there's a kind of human story that we really need to be tapping into as well. Those people believed that they could do stuff and they did it, and we all benefited from it. And I think one of the really big advantages of COP26 is the opportunity to tell these stories. The stories of how it's human endeavor, human ingenuity. Yeah, it's great to be an engineer and I love working with engineers, but it's also great to be a green financier. It's great to be working in the digital space. We've got so much more capability with computing power than we had back in the day, and even back in the kind of 1800s. So there's a lot of much more positive storytelling that we can use to solve the challenges, and I think the Clyde is particularly well placed for drawing on that historical background to reference how it's been done by previous generations and how we can do it.
Chris, Evangelos, would you like to add to that?
Sorry, I keep muting myself and that causes issues. Yeah, I mean, I completely agree with everything that I said then. I'm a secret anorak with Kingdom Isambard Brunel, and I've read quite a bit of him, but a fantastic engineer, but also an incredible salesman and a visionary, because he didn't necessarily invent anything himself, but what he did do is take a bit from one industry and cross-reference it with a bit from another industry to solve a problem that we were facing. And that's exactly what we have to do now. We are individually and collectively inventing all of these great things that if we do put them together, we can really make significant change. And that's where we're coming together, where the computer control and the advanced materials and the bringing back the sales from the past. We can now use these new technologies on top of the things that we've known forever to really make a step change in our product offering, and hopefully do something really good at the same time. So yeah, absolutely, the past is where we've come from, and it's what we've got to refer to.
Yes, I agree. Too, I think that we should learn from opportunities, challenges, errors we did in the past in order to avoid, let's say, making them again. But I think that the history is not exactly repeating itself. We are at the same, let's say, the situation may seem the same, but the rate by which we are passing through this transition phases is totally different from what we had back then. And I think that there are new challenges and opportunities in where we are right now. We need to act very fast. We need to act checking where we go, minimizing the errors which we are doing. I can see that we are going into a transition phase. I can see that this is something that the humanity has, our civilization is doing every few decades, and now the rate is accelerating. Yes, we can learn, but we need to adapt to what we see now and learn, of course, from our previous mistakes.
Thank you. And we also have Mary Leggett would like to ask a question on audio.
Well, it's not so much a question as just first of all to say that the things I've been hearing this morning has been absolutely amazing, and most of it I didn't know about. As I would imagine that most people like myself don't understand. But I know that my wee grandchildren, one's 7 and one's 12, know much more about these things than I do. And that makes me happy, but I also would like for people to look and see how you could take that through to school and speak to the kids about it, because these kids are very, very, very enthusiastic about climate change and everything else. And I think we would miss an opportunity if we don't speak to them about it. Basically, that's it. Thank you, Ian.
Absolutely, yeah, and it's their future that we're putting at risk if we get climate change in the short term.
Absolutely, and I mean, they're the ones who are coming up and who will be going into engineering in different places where they can maybe see things in a different way from we see, and that's a big bonus, hopefully. And I think the future, if the way I'm looking at my grandchildren's school and all the schools around about here, and I'm sure most other places, where the teachers and everybody else are actually enthusiastic about teaching the children about this. So I just think that there is, from that perspective, where yeah, I don't think it's going to be forgotten about like most other things are forgotten about. So just hoping. Thank you.
Thank you, Mary. Diane, would you like to comment on that?
I'd just like to say that I speak to school children quite often about our project, partly because it gives me so much hope about the future, Mary, because you're absolutely right. They know a lot more about it than we do, and it gives me real encouragement that they've got this and that we need to help educate them and inspire them. And so, yeah, I speak to school children if I can. I used to in person, but now I'm doing online courses, online speeches. And next week I'm speaking to some brownies, in fact.
Yes. Perfect. Then the brownies too, and the guides.
Haven't been invited to do guides yet, but as soon as I am, I will.
I didn't mean actually that you didn't know as much as the children. That's not what I meant. I just meant that.
Oh no. I think they've
just
they asked some really tricky questions.
Oh yes, I know that. So it's good to know that our children are aware of what it is in everyday life, and that really encourages me to think that yeah, we will get there. We will absolutely get there at some point. And I thank you for all the things you've been saying this morning, because I've been trying to write it all down. So hopefully I'll keep it in mind. So thank you so much.
Chris, would you like to add anything to that?
If I may, Chris. So, as you understand, coming from a university, we are very interested in educating younger pupils regarding the challenges and opportunities which our profession has in order to attract young talent to our universities and especially our department. I would like to note here that we see that naval architecture is not as attractive as it used to be. Some of the younger persons, they don't, some of them, they don't know that naval architecture is an engineering discipline. They can study what's going on. I think that this also raises an issue of raising the profile of naval architecture in the UK in general, and we are discussing with other initiatives like Marie UK to raise this issue and attract more talent to our sector, because there are a lot of opportunities and we miss this the young persons and the new blood which will actually man all these positions and vacancies which are going to be created when we invest in new technologies and we create the impact which we would like to create. So I think it's very important that we go back to schools and educate people, the pupils in schools, about how interesting is to study in our profession. Thank you.
Chris, would you like to add anything to that? So we're almost so very briefly.
There's not much more I can add to that. I absolutely agree. Michael Jackson had it. We believe the children are our future, so we've just got to get out there and inspire whenever we possibly can, and show them that engineering, which it hasn't been a great industry to be involved in the last 20 years. Engineers have been downgraded through society. But I think we're back. We haven't got enough engineers. We've got far too many problems. So you're beginning to see the wage rates going up for engineers already because there are not enough of us, which is really good. And that will hopefully encourage kids to stop moving towards law and medicine and move back towards the tools. But we just need to keep on being excited about it and tell these stories about the potential things that we could be doing and what a big difference that we can make if we do it right.
Yeah. Well, we could talk all day about this, but unfortunately we are out of time. And there are a few questions in the chat. What I'll do is I'll forward these to the panelists by email, and if they can add comments to them over the next couple of weeks, we'll add that to the video when it's published online. You can find out more about our panelists' organisations on their websites. smartgreenshipping.com for Diane Gilpin's organisation, Smart Green Shipping. strath.ac.uk/engineering for Evangelos, and of course Chris's company, malingroup.com. And if you'd like to find out more information about our Clyde Sustainable Shipping Project, you can get in touch, info@cdpi.org.uk. You can follow updates on our Clyde Sustainable Shipping page at clyde.scot/countdown26. And you can also join in the conversation on our social media. We have a LinkedIn group for Clyde Sustainable Shipping, and we'll publish these links as well. So thank you so much again to our guest panelists today. And thank you all for coming along to this first Clyde Sustainable Shipping webinar. And we hope to see you all at the upcoming webinars in the future.